Good morning, sir. My name is Shivam. My enrollment number is meb19031. Today I am going to solve the given assignment for end-term examinations of computer-aided engineering. My question was modeling and finite element analysis of crane hook. So I am going to do the modeling of crane hook in SolidWorks and going to do the finite element analysis part in ANSYS. So let's start the modeling part in SolidWorks. So for modeling, we are going to select the front plane. Then we are going to do arc, and we're going to draw an arc from this to this, again from this to this. Now we are going to do the dimensioning of the arcs. So dimensions are given like this. It will be 90 mm. Again it will be 190 mm. Now we are going to select the center line, and from the origin point I am going to make 90°, and again from this point we are going to do this. Now again we are going to make an 3-point arc from this point like this, again from this point like this. Now select. Now we are going to give dimensions to this, and its dimension will be 88 mm, and this dimension will be 190 mm. Now we are going to deselect it, and we are going to select it and this line and do coincide. Again this point and this line we are going to coincide. Then we are going to hold this point and going to take it like it this. Now we are going to select this point, this line and this point and make symmetric, and we are going to select this segment and make tangent, and going to select this and going to select this and going to make tangent. Now again we are going to make an arc from this point like this, again from this point like this. Select, and we'll give dimension to this arcs. It will be 152 mm. Again it will be 152 mm. Now you select a circle. We'll draw one circle. give it dimension of 24 mm. Now we will deselect it. We will select this and drag it a little bit. Now we will select this and we'll make tangents, and again we'll select this and we'll make this and we'll make tangents. Now we'll select this and we'll make tangents. Now again we will select this and this circle and we will make tangents. Now what we will do, again we will select this, we will put this, and we will put it somewhere here. Now then we will select this point and we will delete it. Now what we will do, we will select it and drag it to here. Now we will again select it and make tangent. Now we are going to select this point and this point and make horizontal. Again we are going to select this point we are going to select this point and this point and make horizontal. Then we are going to perform the trim operation, and here we are going to trim it and trim this also. Now we are going to select the center line, this point, going to this point, please select. Now again trim, we're going to trim this, yes, and going to make an arc from this point to this point like this. Select, and we are going to select this and and make tangent, and select this and make tangent. Here we have made this trim and again have made a tangent because we want this to be of different parts for further operations. Now select a center line, and from this point to this point draw one, again deselect, again from center line, from this point to this point, again from center line, from this point to this point, again from center line, and from to this point, again select. Now we will select here. Now here 3D sketch, we will select circle, here, separate. Select. Some errors happen sometimes in such modeling programs. Such errors happen sometimes. Okay. From this point again we are drawing. Such errors keep happening sometimes, so we have to avoid such errors. And it is done. From again this part we will make this. Okay, done. Select. Okay, then we will select boundary surface and select this, tick, select this, tick, select this, tick, select this, tick. So now direction 2, right click, selection manager, this and tick. Then again right click here, selection manager, this and tick. Okay, so something like this has happened. Now here 3D sketch, show, 3D sketch, show. Now again we will go for boundary surface and select here, again tick, and go here and tick, go here and selection manager like this, going like this and tick, and again right click here, selection manager, click here and tick. So this is from. So we will remove the unnecessary parts, hide. Now here we are going to select the planar surface, and we select this and OK, and we are going to select night surface and going to select this and OK. So now we are going to select this portion and sketch and going to select the circle and make a circle, and we are going to give dimension to it. The dimension will be 76 mm. Okay, now features, extruded bus, and it will be 203 mm. Okay, now we will go fillet, chamfer, select as here and 5 mm. Okay, chamfering is done. Now we will again go for insert, for annotations, for cosmetic thread, and select this portion and select M24 up to blind and 150 mm and select. Now it is the threading is not visible here, so we'll go in options, document properties, detailing, shaded cosmetic threads. We will tick it and OK. So we can see that the modeling is done here with some threading and chamfering. So from XY point of view, it will be like this. YZ, it will be like this. ZX, it will be like this, and in between it will be like this. Sorry for the inconvenience. This is our crane hook. So the modeling of the crane hook is done here. Now we can see that the crane hull is almost ready. So we will do some minor changes here so that it looks more good. So here we are going to select metals, and we will select polished steel. So the polished steel crane hull is ready. So the modeling part is over here. Now we are going to do finite element analysis part. So till now we have done the modeling part of the given question, that is modeling of the crane hull. Now we are going to do the finite element analysis, which we are going to do in ANSYS, for which we have to select static structural. Now we will select geometry, import, we will import the crane hook, open, geometry is done. Now we'll select model, edit. Now it may take some time to open the crane hook. So this is our crane hook which we have made in SolidWorks. Now we'll select mesh, select generate mesh. Now default, from default we are going to select it as 0.02 and enter. Generate. So this is the mesh that we have generated for cylindrical. If, as you can see, it is somewhat rectangular in shape, and for this part of the crane hook it is triangular. Now mesh is done. Now we will select in static structural, insert. Now we will fix support. We will fix this, select here, here and here. So we are going to fix the whole cylindrical part, and we will select apply. So it is fixed, the whole cylindrical part. This part, that is this part, is fixed. Now again static structural, insert, and we will give standard earth gravity. Now the gravity will be in minus y direction. So we will select solve. So standard gravity, earth gravity is also done. Now we'll select again insert. Now we'll give some force. Now we'll select here vector to components, and in y direction let us give some minus 1000 Newton force, minus because it is in this direction. Here here apply. So we'll solve the force. These are the boundary conditions and other things which you have given to the crane. Now later for post processing we are going to select here deformation total, then again solution, then strain equivalent, then again solution, insert stress equivalent non-misses, solution again, insert energy, strain energy, solution, fatigue tool thing. So we'll do solve. So this is the total deformation. Here it will be minimum, and here in this part it will be maximum. If you can see total deformation. Now let me show one more thing. For true scale animation total deformation, for true scale it is not, the crane hook is not moving. Now that is, we can't see it as moving from our naked eyes. So let us use auto scale and again animation. So total deformation for crane hook and auto scale the animation. So we can see the deformation will be like this. For again equivalent elastic strain, it will be like this. Maximum will be in this portion, in this region. Again, if you want to see auto scale animation, it will be like this. That is, it is visible. The equivalent elastic strain is visible if we use the auto scale animation, but in case of true scale animation it is not visible to us because the values here are very small. Similarly, equivalent stress true scale animation will be like this, will be like this. If you can see the equivalent stress here, it will be the maximum. If you can see this again, this portion equivalent stress will be maximum. Now for true scale, the values are so small that we can't see the movement of the hook with our naked eyes. So for auto scale, the animation will be like this. Movement can be visible with the naked eyes. And last but not least, strain energy true scale animation movement. Again, it is not visible with our naked eyes, but for auto scale we can see it with our naked eyes. Yeah, the movement will be like this. Now one more thing, if we see the strain energy here will be the maximum strain energy. Okay, so here will be the maximum stress energy. So with this, I want to conclude my part. Thank you, sir. Thank you.